Good morning, Professor. My name is Mo, and I'm trying to join your famous lab to do research about mobile robot navigation, path planning, and SLAM. Today, I will present my research in the following topics. And my research background is mobile robot navigation, path planning using geophysical information. And in this big topic, I propose three big ideas. One is geophysical navigation and object detection method. And in this topic, I propose three ideas. One is underwater object detection based on the gravity gradient inversion method. Another is the integrated navigation system based on the geophysical information fusion. Thirdly, I have proposal idea about geophysical reference map modeling, and I use two ways to prepare the geophysical reference map. One is based on the global geometric model. Another is based on the local magnetic anomalous data. And another research is motion planning, and particularly I use the artificial gravitational field function with the physical inversion method to realize the motion planning, and actually I use the shape-shifting robot and UAV to prove this method. And recently, I'm doing some research focused on UAV landing. And in this research, I mainly use UWB localization technology to combine with the physical inversion method to realize the UAV landing. So, this is my research topics and ideas. So, what's the meaning of the gravity gradient? Actually, in our environment, if we have a mobile robot, and on this mobile robot, we can put or install a gravity sensor. And if there is an object in our environment, and if there is a distance between the object and the mobile robot, so we can use this equation to define the gravitational field caused by the object. And in this equation, x, y, z means the coordinates of this mobile robot, and this three letter means the coordinates of the object. So, after doing the second derivative of this function, we can get the gravity gradient tensor. It means that the object can cause the gravity gradient anomalous on this mobile robot. So, if there is a close distance between the mobile robot and the object, in this way, we can use this continuous gravity gradient tensor to present the gravity gradient anomalous caused by the object. If there is a big distance between the mobile robot and the object, actually we can use this discrete gravity gradient tensor to present the gravity gradient anomalous caused by this object. After getting this discrete gravity gradient tensor, and actually we can use some mathematical calculations to get these equations. In this equation, theta and phi means the relative orientation between this mobile robot and the object. R means the relative distance between this mobile robot and this object. So, in our environment, we can use these equations to realize underwater object detection. In our environment, we can also use the UAV or other self-driving car to use these equations to realize object detection. and this is a small demo, and I use the ROS and Gazebo to rely on the virtual object detection demo. And in this demo, I use the ROS node to rely this method, and I use the Gazebo to describe the 3D simulation and 3D environment. So this is the demo. And another research is integrated navigation system. And in this integrated navigation systems, there are two local systems. One is geometric navigation system, another is gravity navigation system. And there are two local systems, and the two local systems are designed by UKFs. And I introduced the information field model. And in this information field model, the input are state installations from each two local systems, and the information field model can output the optimal result. And I use these inclusions to define and design the information field model. And I also use the neural network to design the information field model and get the optimal output. Then optimal output can be feedback into the two local systems to update the state installations in each two local systems. And this integrated navigation system can improve the performance of each local systems and reduce the noise and disruptions from each two local systems. So this is my idea, the integrated navigation system. Another research is the reference map modeling, and I use the global models to prepare a large-scale large reference map. And recently, there are two famous global geometric models. One is IGRF, another is WMML 2005, such the inclusions of IGRF. And however, if we would like to prepare a small region, small scale reference map, maybe in this way we can use the gravity or geometric sensor to do the measurement about the magic anonymous data. And after getting the measurement of magic anonymous data, we can use the polymer fitting algorithms to prepare a small region, small scale reference map. Compared with the large scale, large region reference map, maybe in a small region, maybe the geometric anonymous data can be easier to prepare a small region, small scale reference map. The map is full of character, and actually we can use this map to do the SCP or imagery matching process. And actually this local geometric reference map can be very easier for us to do the geometric navigation. Another research is motion planning, and in this research, I use the artificial gravitational field function with the gravity gradient inversion method together to realize the motion planning. And in this way, I designed the recursive gravitational field function based on the gravity gradient inversion method. And I can put a gravity gradient sensor on this UAV, and in this way the gravity gradient sensor can detect the gravity gradient anomalous. After getting the gravity gradient anomalous data, we can use this data to calculate the relative distance between this UAV and the obstacles. And actually, the relative distance can be derived in recursive potential field function, and so we can use the APF to combine with the gravity gradient inversion method to realize the motion planning for this UAV, and maybe we can also use other mobile robot to test this method. This is my current project, and this is my initial ideas, and I use the UWB localization technology to locate this UAV, and I can put the small gravity sensor on this mobile robot, and the gravity sensor can detect the gravity gradient anomalies. Then we can use the gravity gradient inversion method to calculate the relative distance between this UAV and the mobile robot. The relative distance can be considered as the objective function. When the objective function reaches the minimized values, it means that the relative distance between the UAV and the mobile robot reach the minimized distance. In this way, the corresponding coordinates on this mobile robot can be considered as the optimal landing point. So, we can use this way to realize the UAV landing on this mobile robot. And actually, we can use the ROS node to set the optimal coordinates to this UAV. After receiving the coordinates and commands, the UAV can land on this optimal landing point successfully. So this is my initial ideas about this UAV landing. And in the future, maybe we can use the visual landmarks to combine with the UWB localization technology to control the UAV land on this mobile robot. In future, I hope to do the following research. One is the geophysical based SLAM, and actually I'm trying to use the gravity gradient inversion method to rely on the vertical SLAM or other kinds of SLAM. And secondly, I'm trying to do further research about the multi-sensor fusion. Another research interests swarm, robotical cooperative navigation, and path planning, and I'm trying to use 2 or 3 or more robots together to realize multi-robot path planning, and I hope to use geophysical information, visual information, and LiDAR and other sensors together to realize the swarm robotical cooperative navigation and path planning. Finally, I'm trying to continue my research on UAV landing, and I hope to use the visual information, geophysical information, and the UWB technology together to realize the UAV landing on the mobile robot. So this is my future research plans. Thank you, Professor. Please give me some suggestions about my research, and I'm hoping to use this PPT to impress my background, and especially I'm hoping to join your famous lab to improve my understanding and academic abilities in mobile robot navigation, path planning, and SLAM. Thank you. Bye, Professor.